Okay, this is the second example for the first fit, best fit, and worst fit memory allocation strategy. Okay, so here we have five memory partitions with the sizes 10 KB, 20, 15, 25, and 30 KB. Then we need to allocate the processes P1, P2, P3, which is sizes 18, 19, and 12 KB. Okay, so here we need to allocate with the this process P1, P2, P3 inside the five memory partitions, which is suitable. So we want to apply first fit, best fit, and worst fit algorithm. Okay, so here the first fit allocation strategy, that means P1 equal to 18 KB, which is size. First fit allocation means which is the memory location is enough to store that particular process, first location which is enough to store that particular process, that memory location which is allocated with the corresponding process. Okay, this is the concept called first fit allocation. So here we need to compare from the starting location onwards with the size of process. Okay, so here we need to allocate P1 process 18 KB. From starting 10 KB onwards, we need to search. So 10 KB, which is a free space, which is an available space, but it cannot occupy P1. So the memory block size is less than the process size. So the next block 20, which is compared with the process size. So 20 is greater than 80. So which is enough to the first location, which is enough to store or occupy P1 process. So then we need to find out the remaining memory wastage 20 minus 18 equal to 2. Is it? So here the block 2, which is the first fit to P1 process. So here P1 is allocated to block 2. The next process P2, which contain 19 KB of size. So the starting location onwards, we need to search 10 KB, which is not enough to store P2 process. So the next block 20 KB is already allocated P1. Then 15 KB is the third block, which is not occupy P2 process because the size is 15, P2 process size is 19. Okay, so the fourth block 25 KB, which is already available space, this is enough to store P2 process. So here the first location which is large enough to store P2 process is memory block 4. Okay, 25 KB. So here we need to find out 25 minus 19, 6 is the remaining memory wastage. So here block 4 is the first fit to P2. So here P2 is allocated inside the block 4. Then the next process P3, 12 KB. So from starting onwards, we need to check 10 KB is not enough to store P3, 20 KB, which is already allocated P1, 15 KB. Then this is the first fit location or first suitable location to allocate or enough to store P3 process. So here we need to calculate the memory wastage. 15 minus 12 equal to 3. Again, the block 3 is the first fit to P3. So P3 will be allocated inside the block 3. Okay. After the first fit allocation, this is the allocation strategy of P1, P2, P3 process, which is block 2 is allocated P1, block 3 is allocated P3, block 4 is allocated P2. Okay. So here this is the first fit allocation strategy's result. Then the best fit allocation, that means that we need to search from the starting location to ending memory location, which contain which location is enough to store that particular process. We need to find out the least memory wastages. Okay, so from these locations, in which location which contain least memory wastage, this is the best location to allocate that particular process inside that memory block. Okay, this is the best fit allocation strategy. Here 10 KB for allocating P1 process, starting from the P1 process, this is the size with the 18 KB. So from 10 KB onwards, we need to check 10 KB is not enough to occupy P1. So the next space 20 KB, which is enough to store P1 process. So here we need to find out the memory wastage. 20 minus 18 equal to 2. Then the next block we need to, every location, every memory block we need to compare in the case of best fit location. Okay, so 15 kb which is not enough to store p1, then the next block 25 kb which is enough to store p1 process. So here we need to calculate the memory wastage. 25 minus 18 equal to 7. Then the last block 30 kb which is also enough to store P1 process. So here we need to calculate the memory wastage. 30 kb minus 18 kb equal to 12. So from these memory wastages, in block 2, it contain least memory wastage, that is 2. Okay, so this is the best allocation or best location, suitable location to allocate P1 process. Here block 2 is the best fit to P1, so P1 is allocated inside the block 2. Okay, so P2 process, which is the next process, is P2 process, 19 kb which is the size. So from starting onwards we need to find out the suitable location and also to find out the memory wastage. So 10 kb which is not enough to occupy P2, then 20 kb already allocated P1 which is not a free space. So the third block, the 15 kb which is not enough to store P2 process because the size is less than process size. Then the fourth block for 25 kb which is enough to store P2 process, we need to find out the memory wastage. 25 minus 19 equal to 6. Then the last block 30 kb, we need to find out the which is enough to store P2 process. Then only we need to find out the memory wastage. Okay, we firstly find out, initially we need to find out which is enough to store that particular process. Okay, after that we need to find out the memory wastage. 30 minus 19 equal to 11. Okay, so here which is the least memory wastage? 6 is the least memory wastage that contain memory block 4. Okay, so here block 4 is the best fit to P2, so P2 is allocated to block 4. Then process 3 which is need to allocate from starting onwards 10 kb, we need to compare. 10 kb is not enough to store 12 kb process P3. Then the next block 20 kb is already allocated P1. The next block 15 kb which is enough to store P3, so we need to find out the memory wastage. 15 minus 12 equal to 3. Then the fourth block 25 which is already allocated P2, this is not a free space. So again the last block 30 kb is already available space. So here we need to find out P3 is already or also enough to store P3 inside the 30 kb. So here we need to find out the memory wastage. 30 minus 50, 13 minus 12 we need to find out. Okay, so 18 will be the 18 will be the block 3's memory wastage. So here the least memory wastage will be 3 is the best suitable location which is need to find store the process 3. Okay, so here block 3 is the best fit to P3, so P3 is allocated to block 3. Here the last location 30 kb, we need to find out the memory wastage with the 30 minus 12 kb is the P3 size. So here we need to find out 12 kb. Okay, so here the result is 18. I wrote already 15. That's my mistake. Okay, so you need to mention about 30 minus 12 equal to 18. Okay, then after the best fit allocation, we found this is the best fit suitable allocation strategy of P1, P2, P3. So block 2 which is allocated P1, block 3 which is allocated P3, block 4 which is allocated P2. Okay, so after the best fit allocation, this is the allocation of P1, P2, P3. Then next allocation strategy is worst fit allocation. Here we need to find out the similar type of or same strategy of the best fit strategy. We need to find out or we need to search from the starting location to the ending block. We need to search which is enough to store which processes. Then the available spaces, from among that available places we need to find out the least memory or the memory wastages we need to find out. From here which is the largest partition which contain or large memory wastage or highest memory wastage, which will be the worst location we need to prefer for storing a particular process. That is the condition for worst fit allocation. Okay. In the case of best fit, we need to find out the least memory location, least memory wastage location. This is the best location. So here we need to find out the highest partition which contain memory wastage. Okay. So the large memory wastage space, which is the worst location, we enough to store the particular process. So here the P1 process, starting from the P1 process, 18 KB, which is the size. From 10 KB onwards, we need to search. 10 KB is not enough to store P1. The next block is 20 KB, which is enough to store P1. So here we need to find out 20 minus 18 equal to 2. Then 15 KB is the third block, which is not enough to store P1. 25 KB is the fourth block, which is enough to store P1. So here we need to find out the memory wastage. 25 minus 18 equal to 7. Then the last block 30 KB, which is enough to store P1 process. So here we want to find out the memory wastage. 30 minus 18, that is equal to 12. So here the largest or highest memory wastage is the last block 5 is the highest memory wastage. Okay, so that is the worst location which is allocated P1 process. So block 5 is the worst fit to P1, so P1 is allocated inside the block 5. Okay, then next process is P2, which is size 19 KB. So here from the starting location 10 KB, we need to search. 10 KB is not enough to store P2. The next location 20 KB, which is not enough to store P2. Then third 20 is enough to store P2. So here we want to find out the memory wastage. 20 minus 19 equal to 1. Then the next block 15 KB, not enough to store P2, or we cannot occupy P2. Then 25 KB, which is enough to occupy P2. So here we need to calculate the memory wastage. 25 minus 19 is equal to 6. Here and then the next block 30 KB, which is already allocated P1. So it is not a free space. Okay. So here we found already two memory suitable location we already found. So from that highest memory wastage, it contain block 4. Okay, so this is the worst location which is available or which is suitable to allocate P2 process. So P2 is allocated inside the block 4. Then P3 process 12 KB, which is the size. Then this is same method or same iteration. From starting block onwards, we need to compare. Okay, 10 KB, which is not enough to occupy P3. So here the next block 20 KB we need to search. 20 KB is enough to store P3. So we need to find out the memory wastage. 20 KB minus 12 KB, 8 is the result. Okay. Then 15 KB, which is also enough to store process P3. So here we need to calculate 15 minus 12. That is the memory wastage 3. Is it? Then the next block 25 KB already allocated P2, 30 KB already allocated P1. These two blocks are not free. So here we obtained two memory locations are the suitable or for the P3 process. Here we need to find out the worst memory location which is need to store P3. Here the highest memory wastage is 8. So here that is the worst fit location for the P3 process. Block 2 is the worst fit to P3. P3 is allocated inside the P3 block 2. Okay. So then the result of first fit allocation, this is the allocation strategy. 20 KB, this memory block which is allocated P3. Then 25 KB, which is the location which allocated P2 process. 30 KB, which allocated P1 process. This is the worst fit allocation strategy. Okay, hope you understood. In the case of first fit allocation, we need to find out the first space or first memory block which is large enough to store a particular process. That will be the location suitable to corresponding process. In the best fit allocation, from the starting memory onwards ending memory, we need to search, and whatever the location which is suitable to allocate particular process, we need to find out. Then each corresponding memory location, we need to find out the memory wastage. From these memory locations, whatever the location, it contain least memory wastage, which is the best suitable solutions or location or memory block, which is suitable to allocate a particular process. Then in case of worst fit allocation, we need to find out from the starting location onwards, from the ending memory block we need to search, and each location, whatever the location or wherever the location, the process is enough to store, from that locations we need to find out the memory wastage. In which location it contain highest memory wastage, it will be the worst memory block which is suitable to allocate a particular process. That will be the worst fit allocation strategy. Okay, hope you understood. This is another example for the first fit, best fit, and worst fit memory allocation strategy. Okay, thank you.